Hey, hello, good morning, guys, and this is Coding with Gautam. And guys, today we will be working on our RP software detection part 3. Today we'll be looping through detections and basically identifying the red circle. We're going to be working on this for the whole of today. So let's loop. So first we loop through idxs.flatten. This line iterates over the indices idxs obtained from the NMS function. And then remember, idxs contains the indices of bounding boxes that survived NMS. The flatten method converts any nested structures within idxs, a list of lists, into a single one dimension for easier iteration. Extracting bounding box information, what we do here. So X and Y, boxes I0 and boxes I1. This line extracts the top left corner of X and Y of the bounding box from the boxes list. It accesses the element at index I, and this is referring to the NMS approved box, and it retrieves the first two elements, which are the X and Y coordinates. Then this line extracts the width and height of the bounding box from the boxes list. It accesses the same element and retrieves the third and fourth elements, width and height. Now drawing a bounding box. Cv2.rectangle frame xy. So first we do the color. So when we identify color, this is basically saying that we use the integer c for c in colors of class ID. So c is the color we're using, and remember when we identified colors, this is the random 255, 255, 255, 3 random numpy integers generated to create a random color. We're looping through all that list to identify the random color for the class ID I. So we're just trying to find the color specific for this current class ID that we're using. Then cv2.rectangle frame xy, then we use x plus width, y plus height, and then color, and then 2. So cv2.rectangle, this is the OpenCV function for drawing rectangles on images. The frame is, well, of course we're drawing the frame. X, Y, these are top left corner coordinates extracted earlier. X plus W, Y plus H. This calculates the bottom right corner coordinates by adding the width and height to the top left. So we go from here to the bottom right. Color, this specifies the color of the bounding box. It's obtained from the colors list based on the class ID. Class ID's I using indexing, and then 2 identifies the thickness of the bounding box. So then so text, parentheses, colon, period, 4F, format, classes, and with all that. So this line creates a text string to be displayed next to the bounding box. It combines the following elements. Classes, class underscore IDs I. This retrieves the class name, example person, car from the classes list using the class ID's I as the index. Then confidences I, this retrieves the confidence score from the current detection from the confidence list. This part right over here, this format specifier limits the confidence score to 4 decimal places. Then the dot format, the method used to combine the class name and the confidence score into one single string. So then cv2.put text frame, and wait, before we do, so this is how this will work. So at the end result will be something like person, and it will be like confidence of, it's limited to 4 decimal places, so 96 point, so it will be something like that. So that's what we're looking for at the end. Then we do cv2.put text frame text x y minus 5, and then font Hershey simplex 0.5 color 2. So cv2.put text is the function we're using to place text on images. The frame is the image where the text will be displayed. Text, this is the string containing the class name for the confidence score created earlier, x y minus 5. This specifies the location of the text. It uses the top left corner coordinates of the bounding box, x and y, and offsets it slightly upwards by 5 pixels. Then cv2.font Hershey simplex. This defines the font style for the text. We're using the Hershey simplex font. 0.5 is the font size as a scale factor relative to the image size. Color defines the color of the text obtained from the colors list using class ID as before. 2, this sets the thickness of the text lines. And then checking for the red circle. So circle color equals frame this math. This line extracts a subsection of the frame corresponding to a bounding box area. It uses slicing to access pixels within a specific rectangle. So use y plus h. This selects rows from the y, the top row, to y plus h, the bottom row, encompassing the entire height of the bounding box. Same thing for x. So we take x, and next we do x plus width to the rightmost column, covering the entire width of the bounding box. So, and then 2, this selects only the red color channel, index 2, from the BGR format, color format commonly used in OpenCV images. Then we use the average circle color and p mean circle color. This line calculates the average value of the red color channel within the extracted box bounding area. And p.mean from NumPy computer calculates the average of the elements in the circle color array. So then, if the average circle color is greater than 150, this checks if the average red color value of average circle color is greater than the threshold of 150 in this case. A high red color value suggests the presence of a red object within the bounding box. Then we print red circle detected. If the condition is true, it indicates a possible red circle detection and the message is printed. The functionality allows you to identify which specific colors of the boxes. Then we use Then we wrap it all up with output and exiting. So we use cv2.imshow frame. This line displays the modified frame or image with the drawn bounding boxes labels and any detected red circles if applicable in the window title frame. Then this if loop right here, this line checks for the user input. It uses cv2.waitKey1 to wait for a key pressed for 1 millisecond. If the key is pressed within that time, it performs a bitwise an operation and with a 0xFF 255 in decimal to get the lower 8 bits of the key code. It then compares this value with the key code for the letter Q or the Q. And if the user presses Q, the condition evaluates the true. So basically, it says if we click the Q key, it basically quits it. If the conditional block executes if the user presses Q, this breaks out of the for loop. This means we come here. Cap.release, this line releases the webcam resource and destroy all windows. This line closes up any CV2 windows that were open, ensuring proper cleanup. This is it, guys. This is your code to using AI, machine learning, and NMS to effectively identify objects. Down we use the red circle because I was looking for targets, but you can alter this to your needs, making sure you get what you wish. So you can basically alter this is what you can alter to make sure you get what you need. So thank you guys for watching. Don't forget to like and subscribe, and if we have enough suggestions, I'll make a video demonstrating how this code works in real time using the camera and a target. So yeah, thank you guys for watching. This is Coding with Gautam, and have a good day.